Hello guys. Yep, welcome back to another video. It's been a long and I agree. I haven't been posting any videos after that. It's just as full stop it has been. But it's fine. Yeah, I just quickly wanted to go back to some of the things I wanted to update with you guys, which I think is pretty much important. And sorry for the background. It's kind of like a little bit the sound is pretty much bad, I believe. You might gonna see, like, yeah, there is a lot of background catches there. So, and yeah, definitely I didn't have any other mic right now, so I'm just gonna record it my laptop microphone. I guess that's or else my headphones, which is still looks like a same background voice is coming. I cannot, uh, I, I tried it, but I cannot do that. That voice overlay or something. So, but it's still fine. So let's talk about the dread framework that I'm gonna, uh, you know, the important stuff that I wanted you guys to know before anything happens. It's like I'm just like, oh, I'm gonna go die. Look, before that, if anything happens to me, I just have to post this video. It is like that. But still, okay, let's come back to the point. So what we're gonna talk about today is the dread framework. Okay, it's a risk assessment model used in cybersecurity to evaluate and like to prioritize the threats. What are the basic threats are there, or like whatever the industry standards threats are available. So this frameworks helps a lot of in a pretty much 60 to 70% scenario where you can catch up or where you can detect real-time threats. Okay, it was developed by Microsoft in the early 2000s, and it consists of 5 categories basically. Okay, basically whoever are going for cybersecurity engineers, cybersecurity analysts, cybersecurity managers, SOC managers, and yeah, pretty much who are there in the blue teaming side, they definitely need to look into this one first before going into the analyzing or using the tools and all that. It will help you. I'll show you guys what are the things that you need to look, and I'm also gonna tag some of the links which you might gonna need it to see that. Okay, so let's talk about the dread. Okay, DREAT framework. Okay, which is dread. D stands for damage, the potential impact of a threat, and yeah, DRR is stands for reproducibility. How like easily the threat can be reproduced, and E stands for exploitability. The exploitability means like the ease of the exploiting uh, vulnerabilities. And okay, so that is how like E can be you can take it as, and A is affected users, D is for discoverability. Affected user means the number of users that could be affected. Okay, so you are just going to assess the risk, how many users are going to be affected. Okay, and coming into the next section, which is discoverability, how easily the threat can be discovered. And pretty much this framework helps organization identify and mitigate a serious threats, definitely, but in an effectively by quantifying the severity of risk associated with vulnerabilities. You need to say that this is going to help a lot, in a first stage or second stage. You don't have to go into the maturity phase to implement all this stuff. Okay, now let's talk about see, when you look into the uh, dread frameworks, you will also come up with the stride. There is also another is there, pasta. There are like 3 different frameworks are there, but basically it depends on the people how many things are needed. I'll just gonna make a video of that as well, where you need to find what are the things that you need to look into that and all that stuff. I'm really sorry for the background noise. Okay, so there is one link that I found, which is from the Microsoft itself. If you go into this link, it will show you the threat model for drivers. They have made it like for a drivers. I don't know that I'm also trying to look into it. So they have defined how the threat, how to create the threat models for drivers, create a data flow diagrams. Okay, so this is what we are going to look into it, mainly focus. This is all for Microsoft stuff only, but still it will be helpful for overall, like let's say whatever the, even though if you're running Linux server or any other different servers as well. And yeah, okay, just give me a second. I don't want to coincide, like I don't want to like it kind of going to be disturbing if you hear the background sound, but it's still I'm gonna keep it. Okay, so basically it sure represents a boundary between a driver code. Okay, let's just forget about that. We, by looking at the diagram itself, we're going to understand what is it. Okay, uh, they have designed like you know how operating systems can be, you know, like administrative requests only initiated to initial drivers and how the status. So they probably kept the boundaries between that. So it is like that. Okay. Uh, Even though if you guys go and search for Red framework and look into the images section, you probably gonna find out. I don't know which was that I was talking about. Let me see. Okay, it's not that one. Yeah, man, I need to switch the place. The background noise is too much. I don't know if it's this the threat model. Threat identification model 1. Okay. No, not that. Not that. I don't know. Where is it? Yeah. Let's see. It just shows. It just shows the the yeah. Let's not go back to that point. What we were discussing there. Okay. Image. Let me see if it works. I don't know if they have showed it to us or not, but it's fine. Thread is also the same way, like thread modeling versus thread modeling. Okay. Okay, let's see if they have given this. So what they basically, I'm not finding that image, but we can use this image itself. Okay, so they're also keeping multiple things. Let me come back to the first point. The previous figure showed the data flowing between user process and the drivers, and the omits any intermediate drivers. However, in reality, all requests pass through the IO manager and may traverse one or more higher level drivers before reaching a particular driver. The figure omits these intermediate steps to emphasize the importance of the original source of the data in the context of the thread that supplied the data. Okay, the kernel mode drivers must validate the data that originates in user mode. The information enters the driver because of the request from the operating system, request from the user process, or request typically interprets from the devices. Okay, that just says like you know how the you know interconnection works inside there, but still okay. It all says what are the callbacks, any other interfaces that driver is exposed. Okay, analyze potential threats. How we gonna analyze the potential threats using this threat model? After you identify the points at which a driver might be vulnerable, you can determine which type of threats could occur at each point. Okay, consider the following types of questions. What security mechanisms are in place to protect each resources? Okay, let's say we have firewall, we have firewall, we have endpoint devices, and we have, let's say, what are the other things we can consider? Simply like a VPN or something. Yeah, that would be fine. Okay, we have VPN, firewall, and all that stuff. Okay, we're gonna uh, what security mechanisms are in place to protect each resources. Okay, we have to figure out for firewall how many, like what mechanism we have placed, what are the configurations we are running on the firewall, what are the you know like user securities, like based on the user's access. Does the administration have the access, or like how many other extra users are having those access to the firewalls? All those things, like security mechanisms, in the sense like also like tools it required, but I'm just telling you that in the basic level what we're going to do in the configurations itself. Coming into the mechanism part, yeah, definitely we'll be using the tools there. Let's say if you are using a SIEM tool for that firewall to monitor all the traffic, yeah, that's a mechanism for that. And what are the rules and incidents detections are occurring, and by analyzing the events, by going through the threat hunting, like if you have identified, if you have found out any what do you say, the other rules, like the customizing rules, the user created rules for those firewalls. Okay, that would be the second part. Okay, like, and all that. The next question is, the are all transitions and interfaces properly secured? Like going for the configuration part. Okay, mainly focusing on configuration. The most of the time, like there has to be like a limit for how many open ports it has to be, how many input ports, like how many output ports, and how many people can have the access, like which group or domain can have the access from these ports or not. Like all those has to be defined in a pre-networking uploading stage itself. So that is how it has to be for more securing it. You don't have to go for running a SIEM. You don't have to go for running other tools, putting a XDR, EDR, NDR, IPS detections and all that. To go further, like on the tools part, you can protect it at your core level itself. So that is how the security has to be. But due to the lack of understanding, most of the people are taking less experienced people and putting it directly into the networking sections and configurations, managing admin people's, like the people need to analyze the skill and give the potential. the, Due to the impact, or like due to the pressure of those things and all that company is giving, sometimes HR also like don't even care about it at the end. They just want to hire somebody who can take it with a less, we can take it with a less amount itself. That is how the, like, it has been designed. I don't know if my audio is being audible or not. I'm just gonna stop it here. Let's see. Okay, we need to discuss the third one. Yeah, it's working fine. Yeah, it's working fine. Okay, let's come back to the main point next. Third is, could improper use of a feature unintentional compromise security? Okay, improper use of a feature. Let's say if any of the application is using some of the ports which you don't know, like after at the end of the day, by running a red teaming process or a red teaming assessment, it's most important thing, by analyzing and understanding what are the important ports, what are the important holes that you are not seeing out of the structure itself. Like going into the deep into the packet level itself, you will understand like how many holes are there open that you don't even know. Like anybody can get into that situation. Like you're understanding that situation, right? So that is how you have to be careful within the networking stage itself, before going into cybersecurity, before going into putting a blue teaming or red teaming. Like within a like network, people can analyze the packets itself, right? So they can run the Wireshark, they can run other tools, and they can understand how many packet transfers are happening, like what are the tools. Like they can also run a small nmap queries to find out in what are the vulnerabilities it has been detecting on those devices and all that. But it all depends on how the companies are going for the skill set and all that. Okay, like they have to hire the people properly. Okay, coming to the next section is like, would malicious use of a feature compromise security? Malicious use of a feature compromise security, that is also like defining at your level itself. Like let's say some third party applications are there, but some of the employees or some of the group section in the employee in your company does require those applications to be used for their business purpose, for day-to-day works, and so they might need it for some use. But that application is third party, and also the patches don't be available frequently in this case, means like then you have to consider those things, like you have to put it across with a different scenario. You have to put a lot of restrictions for before configuring those applications in the network. Okay. And do default setting provide adequate security? Yes, this does not provide the adequate security. Definitely you do need to go with the framework structure. You do need to analyze critical users, critical devices, critical ports, all that stuff. Okay. There is a stride framework. We will gonna talk about it. The stride approach to threat categorizing. I don't know, this guy is using something other. They are using something different. Stride means something different is also there. Spoofing, tampering, repudiation, information disclosure, denial of service, evaluation of privilege. Okay, using a stride as a guide, you can pose a detailed question about the kind of attacks could be targeting a driver code. Okay, all this attack. Oh, okay, yeah. This is what it comes in the stride attack basically. Spoofing. I'm gonna discuss this deeply, okay, before going into the. But to implement this whole dread, you need to be using stride as well. So it's like coherently, depends on each other. So that is how the system has been designed. Denial of service or the basic attacks, frequently basic attacks which can happen on any network. Okay. Driver analysis technique, we don't need to look into that. Fast path threat modeling. Okay, they have dread approach to the threat assessment. Here it comes the threat assessment. So they were defining the stride before. Okay, so damage, reproducibility, exploitability, after effects, discoverability. Okay. So they have given score here. Okay, so this is how you will be putting the score or severities on your incidents, on your devices, or whatever you are using. Okay, so dread criterion will for the damage is 8, disrupt work temporarily but causes no permanent damage or data loss. Reproducibility, they have given the score of 10, causes the device to fail every time. Okay, that's a serious threat. Definitely requires a focus effort to determine the command sequence. Okay, 7, exploitability, you can still protect that at some core level. Affects every model of this device on the market. Okay, that's definitely critical. Assumes that every potential threat will be discovered. Okay, just by a single open port, all the sections will be open easily. So that is how the things will be, like HTTP, you can say, not going a secure way. Mitigating this problem is high priority. Okay, they have given all the calculating average of that. It's like a 9 score you will gonna get. Mitigating threats, your driver design should mitigate against all the threats that your model exposes. However, in some cases, mitigating might not be practical. For example, considering an attack that potentially affects very few users and unlikely to result in loss of data or a system's usability. If mitigating such a threat requires several months of additional efforts, you might reasonably choose to spend additional time testing the driver instead. Nevertheless, remember that eventually a malicious user is likely to find the vulnerability and mount an attack. The driver then the driver will require a patch for a problem, including modeling in a broader security life cycle process. Okay, they are discussing a lot of things. Coming back, so you can refer this blog, and they have also given some other toolkits as well for other links where you can see Windows security model, what every driver. Okay, kernel mode driver architecture. Okay, Windows hardware lab kit testing for performance, common vulnerability and exposures. You can look in. So every cybersecurity expert knows this link definitely. And CWE is also another one, weakness enumeration. This is like both of them like needs to be important part. And what is this? Common attack pattern enumeration and classification. CPAC MITRE attack. Okay. NIST maintains a site that describes how vulnerability are cataloged. Okay, so I haven't seen this one. Samathe BF. I don't know what is this. Let me see. Next box framework. Okay. Well, many things are there. BF welcomes. BF welcomes. Oh, they have given the API levels as well. BF file API. Oh, it's a good, like a good informative site. Say for file APIs. API runner, Inventor Creator, PI lead, NIST frameworks. Okay. PI generates BF vulnerability specifications in .bfv format. BFV specification download. Key required. I don't know what they're implying here. Okay. So you need to log in there definitely to see further what you can do or what you cannot. They do have some publications as well. Papers also there. Okay, last 24. They are not active also, man. What the hell? They're not active. Bug frameworks for definitely it's a bug framework. Why they should be active? Yeah, my bad. My bad. I'm not gonna think about it. Formalization. Many things are there, like how they define and what are the evaluations they give, what you can protect, what you cannot. Many things we can look into this one. Nice websites. You guys also need to look into it. Okay. Yeah, this was the another laboratory exercise for risk assessment using a DREAD framework. Okay, information assurance and security. So they have given like I don't know who this Sir Abraham Tinga is, the one who has published this. You can find this document in studio document. And yeah, they talk about program outcomes, about this, like what you will get out of this is basically they will explain the threat framework, and the, they are referring to OAS basically. So you need to think about that one. Okay, when they are for each category, right, this lab will be using the scoring system described by OS. Okay, the scoring system has been defined defined based on the OS. Okay, laboratory activity using the scoring system to access exploitability, damage done. Okay, using the system to assess the risk, describe vulnerabilities. Okay, they are like it's pretty much understandable at a stage itself. Like if you are into a basic level cybersecurity analyst or red teaming, anywhere you will understand this. Okay, like how they compose these questions and what all the, it's just a small one, but yeah, definitely it worth a looking. Okay, the main thing that I need to talk about is this one, the threat modeling. Yeah, the threat modeling path that they have kept in the tryhackme. So they have I haven't logged in. I don't want to log in, guys, but let's just see from here itself. They do have introduction, threat modeling overview, and they have modeling with MITRE attack. Yeah, you can use the MITRE attack. Yeah, that is fine. So many people will come at like MITRE attack. I don't know why like most of the people just fall into that pit before even going into the the surface itself. Like understand at a surface level, there are frameworks, there are policies, there are GPOs that you can enforce or that you can ask before going depth into the just putting it like a. I believe like some people looks like they are cool when they talk about MITRE attack. Like when they're like, yeah, we are using the TTP, so we are using the OTPs. Like, fuck, man, you are not you are not protecting it. You are just scraping some of their money just for your profit. I don't like that one. Okay, so let's not let's just focus, okay? The third task they have is modeling with MITRE ATT&CK, mapping with attack navigator. Here comes the threat framework, stride framework, pasta framework. Yeah, these are the all three frameworks that I was telling about. I cannot show you guys what other things are there. It's like cool, and it's not a cool also. Like it also gives a lot of information. So you do need to complete this whole room. I suggest you guys to go with that one. I'll also post the link for you guys if and it's just takes 60 minutes, so I believe it would be fine. It would be a good you know good information. You will get something out of it. Putting into the practice, it's also all what matters for you guys. Okay, so that is what I'm gonna talk about, and I'm not gonna stretch this video long. And it's been so long back after so long, so many months later, I'm coming back after 1 or 2 years. So let's just end this here, and I hope I do need your I do need your guys support to coming back to this one, doing all the structures. I do have many things in my mind, like I cannot express it within some videos, within 1 or 2 videos itself. I do need time to prepare them. I do need to simplify them for them to understand. Like I just don't want to put everything in front of you. That you can do that by you just searching into the Google itself. But like where we can stop, because at this point, at this rate, what is happening in the cybersecurity field itself is like you are being in a place where, like, if you want to come into cybersecurity, okay, there are hundreds of another options are there for you, where you need to choose where you need to go. Do you want to go SOC? Do you want to go malware analysis? Do you want to go threat hunting? Do you want to go this one, red teaming? Or so code reviews, multiple things are there, man. Right now, I believe people might get confused as well. But from where you come, where you go, that is also what matters. If you have a basic network understanding, and if you don't want to drip down into it more, like you don't want to drag yourself to the bottom of the cybersecurity. If you want to stay in the at the at the surface level itself, okay. So then, like, I believe the most of the thing is SOC itself. Coming into the SOC is like the most easiest path that you can take. But still further, if you want to go in a mid range, you can go for the red teaming. You can go for malware analysis, which is going to be a reverse engineering process, which is like, I believe, if you have, like, for a malware analysis and reverse engineering, you definitely need a coding experience. You definitely need to have you definitely have to been worked in any code level in other organizations, or like if you are a developer or something, then that path would lead to you in a good levels. And also, like, if you guys are coming from a different perspective, let's say I just want to, like, uh, design the architecture. Architecture is also another phase, like cybersecurity engineering phase. As these days, those things are not being defined properly. Like they are taking a network administration into cybersecurity engineering sections, and they're just telling to configure everything and set it up and work it on. So, but I believe that is not what it's supposed to be happen. And I do believe most of the researchers do agree with that. Like you don't need to keep a admin level or network level person in a cybersecurity engineering phase, because that person defines the whole project, defines the whole architecture, defines what tools are to be needed, what tools have been in a good shape, that or what tools are the better here in the option. Like those are the things that they need to keep in mind, and what are the configurations they need to do, what are the frameworks they need to apply, and all that stuff. It all defines by an engineer, but still people are just misusing everything, and that is how it is happening. But still, at the end of the day, we learn many things, I guess. And yeah, my mouth is not stopping, guys, because I've been back from a long time. I guess I cannot stop, but still I'm gonna stop it here, and we'll just gonna finish it off. And sorry for the background noise, and we'll continue this forward in the next videos and all. and you guys please subscribe. Sabas. I do remember that, that video of that boy who was just recording a YouTube video like Sabak. So I suggest you guys to subscribe, like, and share this video, and keep supporting for me to come back onto this path of sharing you my knowledge and whatever that I can do for you guys. Thank you. Thank you for watching the video.